Hello guys, in this question we are going to discuss bottom view of a binary tree, and I think you already know about binary tree. Now we will talk about bottom view of the binary tree. Okay, first read the question. Given binary tree, print the bottom view from left to right. A node is included in bottom view if it can be seen when we look at the tree from bottom. Okay, now how to deal with this question? Firstly, we go to the whiteboard, then I will explain the question. Now, how will I and you find the bottom view of the binary tree? So, to find the bottom view of the binary tree, what we will do these such lines. Later, I will tell you why I am drawing these such lines. Firstly, listen what I am saying. Listen. By drawing these lines, we can observe the bottom view of the binary tree. Look closely at each line. At each line, what is the bottom view of the line? For the first line, the bottom node is 5. For this line, the bottom view is 10. For this line, bottom view is 10. For this line, bottom view is 14, and for this line, bottom view is 25. And that's our answer. So how? So that's the intuition behind how to find the bottom view binary tree. By drawing such lines, we can actually find bottom view of the binary tree. Okay. Now from this, if I draw these lines, I have these lines. Now at this line, what is the bottom view of the binary tree? Is 3. At this line, what is the boundary? At this line, suppose close look at line. What is the if you go from the bottom, if you see from the bottom, which node you see first? If I go view this line from the bottom, I will see 1. Okay, 1. And I in this line, if I will see the last node is 2, the bottom node is 2, the answer is 3 1 2. And in this example, if I do these lines, okay, now at this line, first line, what is the last node which can be seen from the bottom is 14. Okay, now from this node, sorry, from this line, what is the last node we can see is 20. Now from this line, what is the last node we can see is 60. Now from this line, what the last node we can see is 30. Okay, so we have to print this. So how we can print this? Okay, so let's go to the question again. To find the time and space we are required to solve the question in the given constraints. Any constraint? No, the time I have discussed with the examples. Now the time is given n log n, and the auxiliary space is given n. Okay, from these two constraints, what intuition I can build? I have to use a space and n log n. Then n log n is used for sorting, but here there's no, you know, no practicality to use this sorting. So what we can do now? Let's come to the whiteboard. Now these type are the special types of question. These are the special type questions like the vertical traversal of the binary tree, bottom view of the binary tree, top view of the binary tree. For that such purposes, we use QDataStructure, Q and map. Firstly, listen what I am saying. Then, as you go in this video with the flow, you will understand why I am using Q, why I am using map, and definitely understand the question very well. Okay, now as you know, I have taken this queue, and in the queue I have taken a pair. I am storing a pair in the queue. In that pair, the first part of the pair is contains a node, the address to a specific node, and the second part is contains an integer value. Okay, I have taken a queue. Listen very carefully. You will understand the question in next 5 minutes. Okay. I have taken the queue. I have stored a pair in this queue, and in that pair, firstly I will store the address of their node. Okay, then an integer value. Okay, ठीक है. Then we have user map data structure. This is the initial things of this question. Okay, now I will explain why I use this. Now I push the initial in the root. Sorry, in the queue. I will explain this in the later. Now I am going to the most critical part of this video. So listen carefully. Oh, hold on a minute. Yeah, this. Okay. I have to write. I have push queue push. I have pushed a pair before this while loop root and 0. Okay, root and 0. Okay, I have already pushed this. Why I am pushing this? Let's see. Now, as I had told you earlier in the first few minutes of this video, while I am explaining what is the bottom of the binary tree, I have introduced you to the concept of line. Okay, the concepts of line. Okay, so how can we know that which nodes are in the line? That which nodes are in specific line, and fourth, after knowing that which nodes are in specific line and to how to build the bottom node of that line. So for that, we will use a concept which is a very simple concept. Listen, see. As you know, I have pushed 0 in this queue. What is means? Suppose that for that root I have pushed 0. What I am going to do that if I go to the left of a specific node, I will subtract -1, and if I will go to the right of a specific node, I will add 1. Again repeating it, if I will go to the left of a specific node, I will subtract 1. If I will go to the right of the specific node, I will add 1. Okay, this will give the horizontal width of this binary tree. How this binary tree is horizontally width. Okay, now don't be confused with the horizontal. I have used a extra term, but don't be confused. Just to know the nodes in a specific line, we are using this. And how? Suppose firstly we are in like we are in root, we initialize our integer value 0 to the root. Now we go to the left of the root and we subtract -1. Okay, now and from that root 20 node, we go to the left of it and subtract minus from the that current value is -1. So here the 14 node will receive -2 value. Okay, now from that 20 node we will go +1. Sorry, we will go right of it, and while going right of it, I have already tell you I have to add +1. Okay, in that value, the current value is -1, so I have to add +1, which is -1 plus 1 is 0. So the answer is 0. Here the answer is 0. And similarly, if I go to the right of this 10 node, I will have to add +1. So 30 receives a value 1. Okay, now if I will go to the left of the 30, I will subtract -1 from it, and it will go to 60 receives 0, and it will receive 2. Okay, now wow, after allocating these values, what is the benefit? Now see the benefit. Now I now from these values I know the nodes in a specific line. How? See, I have to do the binary effectively. So as you can see, focus. If you see by focus, you can see that lines are like that. Okay, and if I listen, the value -2 represent this line, minus 1 represent this line, and the value 0 represent this lines, this node which comes in a single line, and 1 represent all the nodes in that line, and all the nodes in that line have value 1, and all the nodes in that line is well have value 2. What I am trying to say that uh, the all the nodes which lie for a specific line will have the same value. Means the for the first line, this line, I have to use different colors so to understand better. Like that, yeah. For this line, the n number of nodes will come in this line. The value associated with these nodes is always -2. Okay, if n number of nodes come in this line, the value associated with those nodes is -1. If n number of here 3 nodes are coming in that line, so all the nodes have value 0. Similarly here. So our 30% question is solved. Now just we have to traverse it by using map. Okay, now how to traverse it by using map? Okay, now move to the execution part. As you already know, I have taken a queue which stores a pair root. I have initialized the value which stores a node and an integer value. I have initialized this by root comma 0. Okay, the initial member of this. Okay, now I have assigned a pointer current curr to that queue. Now I know I know that the first element of the root is a node and the second element of the queue is integer value. So to extract these values, we use this. We get a node p. So to extract the first value of the queue and an int variable to extract the second value of the queue. Okay. Now what we are doing that we are traversing. We are traversing. And how we are traversing like that? We can diagram. Firstly, we are diagramming from the start so you can understand properly. Okay. Here we can diagram. Okay. Now uh, p becomes what is a p becomes? P will become root. Okay. Firstly, p will become root and hd will become 0. Okay. Okay. And now m of 0. M of 0 when hd is 0. Now it will go to this. It stores the value with respect to that value in that node in the tree. Okay, so at 0th this node comes 10. I have why this is why we are storing this I have already tell you. So to know the nodes in a specific line, so now the 0th pointer will store all the nodes in that specific line. Okay, and one more thing to tell you, if we go through the end nodes in that specific line, so what we if I see from that in this line, I'm seeing two nodes, two bottom view 50 and 60. Okay, is we have to print 50 60 both or we have to print only 60? Tell me. If we go to this, the output Yeah, sorry. Why we come there? So what we are going through two nodes, 50 and 60. So we have to print both, or we have to print 60. We have to print 60. If we go across to the n number of nodes in a specific line, then we have to print the bottommost and rightmost. Here the bottommost is 50 and 60 and the rightmost is 60. So we have to print 60. Okay, and the map will automatically store 60. Okay. Uh, uh, Coming back to the question, where we are, where SD value stack, sorry, SD value 0 it stores. Okay, now it stores the value with respect to that line. Okay, now now it will go to the left and right of this tree. Firstly, I have to do this tree neatly so you can understand the dynamic of the program. Now I have drawn the tree neatly for you. Now when now the value of the p, the first pair, the node, it will check to the left and right side of it. If they exist, if they not equals to null, then they store in the queue in the form of the pair. Firstly, the node, and the second is the value minus one, one, minus one, and here it will store one. Don't confuse with this n. I'm I mentioned this n because you don't confuse with the 20. If I write 20 or minus 1 here, you can confuse with if they are both are integers or not. I have write n here because so you can see that this part of this pair is a node and this part of this pair is an integer. Okay, now it will store like that. Here the queue becomes this. Now the queue is not empty. It will again go to the queue. Okay, now the current will become this. Now the P will point to the 20 and SD will point to the minus 1. Okay, now again, now when SD, when it comes from, when the this it refers, the current is refers to, the P is referring to this, sorry, P is referring to this. Now it will again check. Now it will store its map according to this current value. Now it will again check for its left and right. It will again check for its left and right, and this process will go on continue until the queue becomes empty. Okay, now the now after execution of this, the map will become like that. Now after execution of this previous slide, the previous code, which is written in the slide, the web will become like that. It will automatically store the values in that order because the keys in the map are always stored in the increasing order. Okay, now you just need to print the map, traverse the map and print the second item of the map, and you will get your desired result. Okay, so this is these slides. So this is a question. Firstly, we understand the question, first part of the solution here. Then we come to the initializing the queue part and using a data structure like map. Then the main part of this queue traversing and queue storing, and then the map. So there is only if we, the and the code is here, and if I submit that code and it will run, yeah, it will running successfully. So